So basically in electrical terminology, so we are having three parameters. One is conductor, another one is semiconductor, third one is insulators. So conductor, so we know this is a conducting path. So wherever we are having the low resistance, so the current can easily passing through it. In a semiconductor, it is a bistable one. So it has partially conducted and partially insulated medium. So when we are increasing the supply voltage behind the cut-in voltage, so the corresponding semiconductor will behave as a conducting part. Then third one is insulators. So insulator is which is opposite material property to the conductor. So the insulator has a high resistance basically. So because of this parameter only, it will behave as a non-conducting medium. Okay. So in this here in our transmission distribution system, so we are in need of insulator to separate the line conductors. Okay. So wherever we are seeing our transmission system towers are nearby pole, so definitely we can easily seen about the insulator. So here we are going to discuss about what are the type of insulators, then applications, then what are the range of voltages and the corresponding insulator type. Okay. So basically insulator is nothing but line conductors must be properly insulated from supports. If it is not properly supported, definitely there will be leakage current, then it will be affect the system as also the person who is handling the transmission system. The insulator provide the necessary support and also it should maintain the high resistance and also high dielectric strength. So we are having the properties of insulators. First one is the high mechanical strength in order to withstand the conductor load and wind load. So normally in a transmission system, so we are having the high conductor weight and also the wind velocity also there. So in the insulator should maintain the maximum withstanding capacity, then only it can maximum mechanical strength, so then only it can withstand the conductor weight as well as the wind velocity weight. Okay. And second one is high electrical resistance of the material in order to avoid leakage current. If suppose the insulator have low resistance, means definitely it is possible for the leakage current the entire system, so it will be a very dangerous one. So it should be a high electrical insulation one, and also high relative permittivity of the insulated material in order to that the dielectric strength is high. If suppose your insulator material is not a high permittivity one, so definitely dielectric strength will be very less. So due to this property, if it is less means, so definitely the insulator can easily break down whenever we are facing the voltage spike or rise in voltage. Then insulator material should be a non-porous, free from impurities and cracks, otherwise permittivity will be lowered. So if suppose your material have some non-porous or free from impurities, if it is not like that means, so imperfection in the material structure, so it will be lose your permittivity of the material. So if it is loose means, again the dielectric strength of the material will be less. So we are having a problem in the problem. Then high ratio of puncture strength to flashover. So in a transmission system, the flashover is it happened. So our insulator should maintain and also withstand that puncture strength through flashover. So there will be a standard test for this puncture to flashover. So the ratio will be high, so then only we can utilize for a transmission and distribution system. So what are the materials used for the insulator? Basically we are using glass material, glass as a type of insulating material. So we are using glass as for manufacturing for insulator. Then ceramic, porcelain. So this ceramics is majorly used for the insulation purpose because it has low cost material compared to the glass. And the third one is silicon rubber. Silicon rubber is nowadays they are upcoming in utilizing the maximum of transmission distribution system, because of silicon rubber has a less weight material compared to the porcelain. So transportation and handling of silicon rubber in a very big tower, which is very easy compared to the porcelain as well as the glass material. So types of insulator, basically we are having 4 type of insulators. One is pin type insulator, suspension type insulator, strain and cycle type insulators. So in a pin type insulators, pin type insulator, the structure is here. So we can see this pin type insulator even in a distribution system. So it has a structure of groove of conductors which is fixed in the top portion of the insulators, and the bottom portion we are having galvanized steel pin, and also in betweenly we are having a shade or petticoats, and also we are having cementing. So the structure is so like this only. So why they are going for this type of petticoat structure means, so it will increases the length of the groove to galvanized steel pin. So the length will be increased. If you are seeing in the picture wise, the height is minimum, but the length of the groove to galvanized pin is which is double the time what about the height. Okay, so this will be increasing the length of the arc or length of the leakage current, so it can maintain the withstanding capacity. So this is structure. This pin type normally we see in our distribution system. Okay. So this is the another structure for pin type, the same thing. So the safety factor, so in the previously we discussed about the safety factor. So the safety factor is nothing but puncture strength to flashover voltage. The safety factor is normally about 10, so then only we can utilize for the insulator. So here there is a top portion we are having conductor, the bottom portion we are having the cross arm. So if you are going this petticoat arrangement, so we are having the length which is much higher than our ordinary height of the system. So this is a practical physical view of the pin type insulators. So pin type insulators are normally used in a transmission distribution system of the voltage up to 33 kV only we can utilize, and also behind after operating of 33 kV pin type insulator become too bulky and again uneconomical. Okay, so normally this pin type maximum utilization is distribution only. In a transmission system we will go for the suspension type insulator. So suspension type, so the higher voltage range is above 33 kV, so up to maximum level 400 or 765 kV, so you can utilize. So this type of insulator having number of discs to have, each disc capacity is withstanding capacity is more than 33 kV. It consists of number of porcelain discs connected in series by metal link in the form of string. So this will create a string, so we can utilize this type of insulator for transmission purpose only. So the physical view of the string insulator is here. So we are having the top portion, we are having the cross arm, the bottom portion also we are having cross arm. So in the bottom portion we are going to fix the conductor, in the top portion we are going to fix in the tower. Okay. So in between top to bottom, so there will be a metal link for each disc which is connected to everyone, and also the suspension string insulator having a problem of voltage in the bottom of the disc which is much higher than the top portion of the disc. So this will be affected the bottom portion of the disc, and it may damage. So we have to maintain the voltage from bottom to top in the equal level, so then only we can save the insulator for any electrical hazards. Okay, so that we are going to provide a guard ring of the top and bottom portion, so that it will help to increase the charging current on both the side. So and also we can maintain the voltage distribution equal from bottom portion of the disc to top portion of the disc. So advantages of this suspension insulator are, it is cheaper than pin type insulators for voltage ranges above 33 kV. and each unit of disc suspension insulator is designed for low voltages, usually 11 kilovolt. Depending upon the working voltage, desired number of discs can be connected in series. If suppose we are going our transmission line capacity is 132 kV, so we are going to connect 12 discs in series with the transmission system. So if any one of the disc is damaged, the whole string does not become useless, because the damaged disc can be replaced by the sound one. Okay, so we are having the 11 or 12 disc. So if suppose any one damaged, we can replace it. So so the whole string does not useless. Okay. The suspension arrangement provides greater flexibility to the line. The connection at the cross arm is such that insulator string is free to swing in any direction and can take up the position where the mechanical stresses are minimum. In case of increased demand on transmission line, it is found more satisfactory to supply the greater demand by raising the line voltages than to provide another set of conductors. If suppose in the present case they are designed for one range of voltage, in the future, so they need of more demand, so they are increasing the voltage to 132 some other range of voltages. So they are increasing the number of insulator in the same structure, so we can utilize it for the higher voltages also. So and also the suspension type insulators are generally used with the steel tower as the conductor run below the earthed cross arm of the tower. Therefore, this arrangement provides partial protection from the lightning. Okay, so normally this insulator string, everything is under the ground wire only we are having. So direct lightning strike is not possible, so it will strike only the ground wire. So the entire section will be safe from lightning strike. So the next one is strain insulators. So where there is a dead zone, dead end of the line, or there is a corner or sharp curve, the line is subjected to greater tension. Okay, so from the name itself we can identify where the strain or stress will be more, so we can utilize this type of insulators in order to relieve the line of excessive tension. So strain insulators are used. The voltage range is so less than 11 kilovolt. Then sacred insulators are used for strain insulators. So another name of strain insulator is shackle. Okay, so this is the actual structure of your strain insulators. So we are having some angle deviation of the pole, or some pictures we are going to change the direction of your transmission line. So in that position we need a support from strain insulators. So there is a conductor, we are having the pole, insulators. So both the suspension or strain insulator both are in the same manner. So suspension insulator is in the vertical string form, it is in a horizontal string form. So this is your strain insulator. So if you go with the suspension insulator, it is a vertical form, this is a horizontal form. So this mainly used in the where your transmission tower direction is changed from one direction to another direction. Then this is shackle type insulators. This is mainly used for distribution network only. So we are having the pole, we are having a set of structure from the bottom to top. Then another one is strain insulators. So in our transmission system or distribution network, so we are utilizing the stray wire. So in a stray wire, it is also possible for leakage current. So in order to avoid such worst cases, we go with strain insulator. So it will separate your line conductor and earth conductor, so that we can avoid the leakage current to earth. It is mainly focused for a human safety. So thank you for listening.